Alright, so in this video we cover section 6.2. So actually this section will be split into two separate subsections, if you will, or which will be in two separate videos, 6.2 part A and then section 6.2 part B. So in these two sections, in these two split sections, we are going to add and subtract rational expressions for the first part with the same denominator, and then for the second part with different denominator. Okay, so what's the idea behind? So adding and subtracting fractions with the same denominator. For example, if I have 1/4 plus 5/4, well, in this case, because in this case these two fractions have the same denominator, all we do is carry the denominator, write it down, and do the indicated operation in the numerator and in all the numerators, that is 1 plus 5. So all we do is simplify. 1 plus 5 equals to 6 over 4. But in this case the problem is not finished, because we can still simplify this to further terms. So in this case both numbers are even. We can divide both numbers by 2 to get a 3 over 2. And that would be final answer. Another example, well, in this case, what about 2/7 minus, well, actually, let's put it 3/7 minus 1/7. Okay, so in this case, the denominator is the same. Just bring it. And we are going to have 3 minus 1, which is going to be, in this case, 2/7. And in this case, this is final answer. We cannot simplify this any further. So pretty much this is what we are going to be doing, but in this case with algebraic expressions that depend on x or other variable incidentally. So let's look at the definition. Well, so consider the fractions p over r and q over r. Okay, in which r cannot be 0 again, because if the denominator is 0, then we're going to have an undefined expression, as we went over in the previous couple of sections. Then, well, to combine them, which is exactly what I did. So p over r plus q over r, combine them together, just bring the denominator and add the exponent. Not the exponent, add the numerators, which is exactly what I did at the top of the page with the numerical examples. Okay, so simplify the sum as we did. Like in this case, we simplify the sum. 1 plus 5 equals 6, and divide out common factors. And notice in this case 6 and 4 had a 2 as a common factor, and that was divided out. So 6 divided by 2 is 3, 4 divided by 2 is 2. So we're going to do something similar, but in algebraic expressions. Alright, so a better way to see this is by looking at the examples, doing a bunch of examples. So find the sum and simplify the result if possible well. So in this case, the denominator is the same. Okay, so because the denominator is the same, we can just write it down in one single fraction and then do the operations implied. X squared plus 7x. Alright, so that'll be the potential final answer. However, notice in this case we are expected to simplify to the lowest terms. Alright, that'd be a good idea to highlight this. Simplify whenever possible. Okay, so let's see if we can factor the numerator. So in this case, in this section, all different factoring techniques will come into play. So in this case, looks like we are going to factor out the GCF. So x times x plus 7. And then divide by x plus 7. And as we can see here in this example, we can divide out this x plus 7 with that x plus 7. There you go. And divide out. And final answer is x. Okay. So that's our first example. So let's see. Let's look at what we have next. So we go to the next page. See what's waiting for us. Okay, let's do one more. Letter B. Notice both rational expressions here have the same denominator. So I'm gonna draw a huge line with the denominator, the common denominator, which is x squared minus 4. And all I'm gonna do is combine these two. I'm gonna write 2x squared plus x, and then plus the quantity x minus x squared. Alright, if you want to see this with highlighters, of course we can do that. So all I'm doing here is this quantity and then plus this other quantity here. Okay. And then just in this case, in the numerator, combine any like terms. And as you can see, this 2x squared minus x squared, if we go with the powers, they simplify to simply x squared. And then x plus x, that's going to give us 2x. And then divide that by x squared minus 4. So in this case, we are done simplifying and adding the fractions together. However, in this case we are not done with the problem. If you put this as a final answer on my MATLAB when you're doing the homework, it's going to tell you that although your answer is correct, it's not written in the correct form, and that is because this expression is not simplified. So how do we simplify this? Okay, do we cancel the x squares like this? Well, in this case we cannot do that, because what happens if you cancel terms? So kitty dies every time you do that, right? So in this case we are going to factor out the numerator. In this case we can factor out the GCF, x times x plus 2, and in the denominator we can factor out the difference of squares, x plus 2 times x minus 2. And in this case we can see that we can cancel out or divide out the common factor of x plus 2, leaving us with x divided by x minus 2. And this would be a final answer. Alright, so those are only two examples on adding fractions together. For the subtraction, we need to be very careful about this one, because the negative sign will have in this case a huge impact on how we are going to simplify this example. So, and again, consider the rational expressions p over r and q over r, in which r is not 0 for the reason already discussed. Alright, if r equals 0, well then the denominator is 0, and we cannot have that because it's going to give us an undefined. So subtracting the two fractions together, p over r minus q over r, bring down the r, and then just subtract q from p. So the best way to see this is looking at some of the examples. And in this case we can just combine this together because we have the same denominator, n squared minus 1, n squared minus 1. And all we do is 2n squared minus 2n. So that is our potential final answer. However, we are not done yet, because if you look at these expressions, we can factor them out. So potentially this could be the final answer, but this is not going to be it, and you will see why. So every time you add or subtract the fractions, you need to determine whether you can divide out common factors. So in this case, 2n will be the GCF, and then n minus 1. If we distribute 2n times n, that's going to give us back the 2n squared, and 2n times negative 1, that's going to give us negative 2n. And then divide by the factorization of this difference of squares, n minus 1, n plus 1. And very similar to the previous example, well, we can divide this out, and this is going to leave us with 2n over n plus 1. All right. Let's look at another example, letter B. Letter B. All right. So, let's see. So 9x plus 1 over x plus 1 minus 6x minus 2 divided by x plus 1. Number 1, we can see that the denominator is the same, so all we can do in this case is write a big division bar, and this is going to be 9x plus 1, and in this case minus, be careful here, minus, I would open parentheses, this will be 6x minus 2. Why am I opening this parentheses? Because this negative sign is affecting both the 6x and the negative 2. And the best way to represent that idea is to put parentheses around the second term. We don't need to do it in the first term because, I mean, if you put them, ultimately those are going to go away. It's not necessary when we have a positive in front of it. So in this case, distribute the negative sign. Distribute the negative sign to obtain 9x plus 1 minus 6x plus 2. Negative times a negative is positive over x plus 1. And in this case, let's only combine like term, x's with x's, constants with constants. So 9x minus 6x, that's going to give us 3x. 1 plus 2 equals to 3. Divide that by x plus 1. And in this case, we are potentially done. However, this can be simplified a bit further. Factor out the 3, leaving us with x plus 1. That's 3 times x, 3 times 1. That's going to give us back the region of the previous step, and x plus 1. So what's going to happen here? Cancel, cancel, and the final answer is the number 3. Okay, that's final answer. Alright, let's look at letter C. And by the way, for letter C, we have a silly typo there. This one was supposed to be, we have 2 letters going on. We have 2 letters going on. So, let's fix the letter A, that's supposed to be a W. Okay, so 3W. W squared. Alright, let's see. In this case, well, notice W minus 4 is not the same as 4 minus W. In this case, these two fractions don't seem to have the same denominator. So this is what I'm going to do. So I'm going to use the negative sign property to factor out the negative sign. So in this case, let me use a different color. Keep in mind that A minus B is equal to negative B minus A. So all we're doing is reversing the order of the terms, but putting a negative sign in front of it. For example, 3 minus 4 is equals to 4 minus 3, but with a negative sign in front of it. Okay, what is 3 minus 4? 3 minus 4 equals to 1, and then 4 minus 3 is a 1, but with a negative inside this changes to 1 equals to, actually negative 1 equals to negative 1. Okay, so we're going to use this trick, if you will. It's not necessarily a trick, it's algebra, and we're going to do that. How are we going to treat this one? So pay special attention to this one. All right, so w squared minus 3w divided by w minus 4. And then that's going to be plus negative 1. All right, I'm going to factor out a negative 1 times, instead of 4 minus w, I'm going to call it w minus 4. And 4. Okay. Now, adding a negative number. Adding a negative number, it's the same as doing the following. So for example, 5 plus negative 3. I am adding a negative number. I am adding a negative quantity. 5 plus negative 3 is the same as subtracting 5 minus 3, which equals to 2. So in this case, this adding a negative number is the same as subtracting the quantities. In this case, w squared minus 3w, w minus 4, and then minus w minus 4, and a 4 in the numerator. And if you notice here, we accomplished our goal in this case, which is to have the same denominator. Okay, so as opposed to the previous examples, well, notice how in the first place we got the same denominators. All right, and I'm highlighting them as I speak, just so you can see the difference. All right, but in this case, well, these are not the same denominator. Well, we can use this little trick of factoring out the negative to finally turn them into the same denominator. And what are we going to do next? Well, in this case, write a big fraction with the same denominator and bring down w squared minus 3w minus 4. So we are potentially done. So, well, we are done with combining the fractions together. However, the story doesn't end there. We need to go the extra mile. What's the extra mile? Well, factor out the numerator, and maybe we can divide out something in the denominator. Okay, so in this case we have a trinomial whose leading coefficient is a 1, so we're going to use the double bubble method. Factors of negative 4 that add up to negative 3, k minus 4, and plus 1. Okay, because negative 4 times 1 equals to negative 4, and negative 4 plus 1 equals to negative 3. Alright, so let's see. Notice in this case how w minus 4, w minus 4. And we are going to be left with w plus 1. Final answer. Final answer for this one. Alright, so that's how we treat addition and subtraction of rational expressions that have the same denominator. The next section will deal with combining fractions that do not have the same denominator. But for those exercises, we need to review of how to find the least common denominator and how to apply that to algebraic expressions. So the second part of this section is finding the LCD. What is the LCD? That's least common denominator. Okay, least common denominator. All right, so that's what it is. So how do we find the LCD? Well, So we have the steps here. Factor each denominator. Form the LCD by multiplying all distinct factors. For common factors, utilize the highest power of the common factors. Well, these steps, we'd better see them in action with the example. So find the LCD of this given rational expression. So we might have done this, well, if you took a pre-algebra like Math 35 in this class, in this college, well, you might have taken that class. We will learn how to do that. We're going to review this in this class just so we can, so that comes back, to make it come back to life before we apply it to rational expressions, to expressions that contain variables in this case. So what are we going to do? Factor the denominator. So I'm going to write the number 32 and I'm going to prime factor the number. So I'm going to start dividing by 2. 2 times 16. That's 1. Factor out the number 16. That's 2 times 8. Factor the number 2. That's 2 times 4. And finally, 2 times 2. So we are going to write this in terms of powers of the prime numbers that we got, in this case the number 2 to the 5th power. Okay, let's do the same with the number 48. Okay, so the number 48 is the same as, well, if we divide by 2, that's 2 times 24. If we divide this by 2, that's 2 times 12. If we divide by 2, that's 2 times 6. If we divide by 2, this is 2 times 3. Alright, so in this case, what are we going to have? We're going to have 2 powers of 2 and powers of 3. Okay, how many powers of 2? Well, count the number of 2's. In this case, 1, 2, 3, 4. And then we have only 1 3. That's 2. That's 3 to the 1st power. We don't need to write that one. There's only 3. If we had another 3, well, then it would be a 3 squared in this case. All right. So now what's the LCD? So the LCD will be multiply all distinct factors. Well, what are the distinct factors? So in this case, we have only 2 distinct factors. What are those distinct factors? Well, one of them is the number 2 that I'm going to highlight with pink, and the other factor is the number 3 that I'm going to highlight with orange in this case. Okay, so how are we going to do that? Well, number 1, start by writing the product of the 2 distinct factors and then utilize the highest power of each. Well, in this case, let's look at the number 2. The number 2, it appears here and appears there, but in this case, one of them has the highest power. The highest power is 5. And then let's observe the number 3. Well, the number 3 only appears on the second factor, so we only put it once because it has 1. The power is 1. If we had it to the second power, we would put the second power. So in this case, that's the LCD. We need to simplify this. Well, this is 2 to the 5th power. That's 32 times 3, and that equals to 96. So 96 is the least common denominator. All right, let's do another example in which we combine not only numbers but also variables. So for the numerical coefficients, we are going to do the same. All right, so we're going to do the number 36 and the number 15. Okay, so the number 36, let's start by dividing it by 2. So that's 2 times 18. Divide that by 2. That's 2 times 9. And finally, the number 9, it's the same as saying 3 times 3. Okay, so in this case, we're going to have 2 This is 2 to the second power because we have two factors of 2 times 3 to the second power because we have two factors of 3. Alright, let's do the same with the number 15. This one is going to be easier. Alright, so 15 is the same as 3 times 5, and in this case we're done because both numbers 3 and 5, they are 3 times 5. They are prime numbers, and then they cannot be broken up into further factors. Alright, so let's try the LCD. For the numbers, number 1, okay, so we are going to multiply all distinct factors. So distinct factors, number 1. One of them is 1 factor of 2. Another distinct factor is the number 3. And another distinct factor is a number 5. Alright, so 2, 3, and 5 are the distinct factors, but we are going to utilize the highest power of each. So for example, for the number 2, well, we only have it to the second power. That's the only one that appears. But in this case, observe that we have that the number 3 appears on both. Appears as a factor of 36 and also appears as a factor of 15. But in this case, we are going to take the one that has the power, the highest power, which in this case is 2. And we only have one factor of 5. It needs to the first power, so we just leave it like this. Alright, well, in this case, we're not done, because in this case, if you observe these two fractions together, we have factors of x and factors of y. And we're going to do the same. We're going to look for the highest power that you see of x. In this case, notice we have x to the second power and x to the first power. We're going to go with the highest power, which is 2. If we observe the y, we have y to the first power and y to the third power. We go with the highest power, which is 3. So this would be the LCD. However, if we put this on as a final answer on MyMathLab, it's going to tell us that the answer is correct, but not in the correct format, because we need to simplify this. Well, 2 squared equals to 4 times 3 squared, which equals 9, and then times 5. X squared, y cubed. 4 times 9 is 36 times 5. X squared, y cubed. And 36 times 5 equals 180 x squared y cubed. Final answer, 180 x squared y cubed. Alright, let's look at more examples. So we're going to use so in this case, looks like I have a missing page, am I? Yeah, that's what it seems. Never mind. Okay, so let's look at this one right here. So now with expressions, we're going to find the LCD with expressions, with algebraic expressions, not just numbers and powers of x. Well, so what do we have to do? We have to factor every single denominator. So I'm going to rewrite this too, but in factor form. Well, for the first expression, 1 over x, there's nothing we can do about it. It's already in lowest terms. However, the denominator of the second fraction can be factored out by the GCF, x times x minus 1. Alright, so let's find the LCD for this. LCD will be the product of the distinct factors. So in this case, I'm going to highlight all distinct factors, x and x. Alright, x and x. And then with a different color, x minus 1 happens to be a different factors. So in this case, I'm going to multiply the different factors, x times x minus 1. And in this case, I'm just leaving it like this because in this case, we are actually carrying the highest power of each. What's the highest power of x? Well, x to the first, x to the first. Well, we carry x to the first. X minus 1, the only one that appears is to the first power. That's the one I carry. Alright, let's look at letter D. Okay, so for the denominator of the first fraction in letter D, we can factor out the difference of squares, x plus 3 times x minus 3. That's in the denominator of 1. And for the second fraction, we have a trinomial whose leading coefficient is it's 1. So we can use the double bubble method. Alright. So using the double bubble method, we look for factors of negative 12 that add up to 1. That's going to be plus 4 and minus 3. And that's because 4 times negative 3 equals negative 12. And 4 minus 3 equals positive 1. Alright, so now that we have the denominators fully factored, this is what we're going to do. Find the LCD. To find the LCD, multiply all the distinct factors that you see and to the highest power of them that you see. So I'm going to use pink to highlight x plus 3. Do we see another x plus 3 anywhere else? No, that's it. I'm going to use blue for x minus 3. Do you see another x minus 3? Well, yes, we have it here as well. Alright, and with orange, I'm going to highlight x plus 4. So we're gonna have 3 different factors. In this case, the factor x plus 3, x minus 3, and x plus 4. Okay. Let's look at letter E. Letter E, we have, for the denominator, we can factor out an x times x minus 3, and factors of 3 that add up to negative 6, we are looking for the double bubble method. In this case, we're looking at the double bubble method because we have a trinomial whose leading coefficient is 1. So minus 3 and minus 3. Alright. Now, it would be a good idea to keep rewriting this. So this one, I'm just going to copy it the way it is. But this one, we need to rewrite it in this form. X minus 3 quantity squared. Alright, so it's time to identify the different denominators. In this case, only x. This x does not appear anywhere else, so I'm done highlighting that with that color. I'm going to use a different color to highlight x minus 3 and x minus 3. So this example will probably make more sense because now we're going to finally see that the same factor but different powers of each. LCD. But which power are we going to take? Well, number 1, we take x and times x minus 3. But in this case, we have 2 of them. We have one to the first power, the other one with the second power. The highest power wins. That's the one we take. The one with the highest power. Alright, let's have a look at letter F. So letter F, we have a trinomial, a difference of squares, another trinomial, and the same difference of squares. So we're going to factor everything. Let's factor the trinomial whose leading coefficient is 1. So factors of 25 that add up to 10 using the double bubble method, x plus 5 times x plus 5. And then for the difference of squares, x plus 5 times x minus 5. So that's for the denominator of the first fraction. And then, well, I'm going to factor out these trinomials, factors of 25 that add up to negative 10. X minus 5 times x minus 5. No, negative 5 times negative 5 equals positive 25, and negative 5 plus negative 5 equals negative 10. And then this difference of squares gets factored the same way it is. X plus 5 times x minus 5. I mean the same way we did the previous one. So I need you to observe the following. Yes, you're probably at this point you're looking at a lot of factors, but you might observe that many of them repeat, and I'm going to highlight them. I'm going to highlight the ones that then repeat, like x plus 5, x plus 5, x plus 5, and then I have another x plus 5. On the other hand, we have an x minus 5, x minus 5, x minus 5, x minus 5, but we are not going to be done over here. We need to rewrite these fractions as powers of each repeated factor, that is x plus 5 to the third power, and that's because we have 1, 2, 3 factors of them, and then x minus 5. And then over here, observe the orange factors, x minus 5, x minus 5, x minus 5. That's x minus 5 quantity cubed times x plus 5. So let's highlight again using the same colors as we did. Pink for the x plus 5s and orange for the x minus 5s. Alright, now it's time to find the LCD. The LCD will be the product of the distinct factors, and the distinct factors are x plus 5 and x minus 5. However, we need to look for the highest power of each. In this case, power 3 versus power 1, we go with power 3. For x minus 5, the one in orange, power 1 versus power 3, we go with power 3. Final answer. Alright, the next example, the next and last example of these LCD ones. Well, so we don't have to factor anything. In fact, everything is given already in factor form. Our task here, our job is to identify all the different factors. So let's see, I'm gonna start with pink and highlight x minus 3. So I have x minus 3 to the second power, but the question is, do we see another x minus 3? Well, we have one over here. Okay, and let's use a different color for 3x minus 2. So 3x minus 2. Do we see another 3x minus 2? Well, that's about it. We don't have any of them. All right. So let's see. Let's use a different color for x minus 5. Well, for x minus 5, we have it to the third power, but we don't see another x minus 5, though, so that's going to be the only one. If we had another one over here, then I would highlight it. Okay. But in this case, we don't have one of those. So let's use another color. Let's see, green. So I'm going to highlight 7x minus 1 quantity squared, but we don't see another 7x minus 1. So that's the only one we are going to highlight. And last but not least, I'm going to use yellow to highlight the quantity x plus 5. Okay, so x plus 5 quantity squared. So in this case, the LCD will be the product of the distinct factors, in this case, the factors of each color. So that is x minus 3, 3x plus 2, x minus 5, 7x minus 1, Well, I don't need to repeat this x minus 3. We are only supposed to write it once. We are going to take the highest power of each, so I omit this one, and then I'm going to go with this one, x plus 5. And then in this case, well, for the pink ones that are x minus 3, to the second power and to the first power, we're going to go with the highest power of each, which is 2. 3x plus 2 only appears once and appears to the first power, so we'll leave it the way it is. X minus 5, on the other hand, appears to the third power, but appears only once, so that's the power that goes with it. 7x minus 1 appears to the second power, but it only appears there, so that's the one we take. Alright. So, and finally, last but not least, x plus 5 to the second power appears only there. That's the one we carry. That's the final answer. So what's the idea? Number 1, identify all the different factors that appear and take the highest power of each. Over here, letter F, for example, write down the common factors. I mean, write all the different factors, x minus 5 in this case, and x plus 5 and x minus 5, and then go with the highest power of each, 3 and 3 respectively. Alright, so let's see, let's turn the page, see what's next. In this case, we are going to use the LCD to write equivalent rational expressions. So what are we going to do in this case? Write each denominator in factor form, find the LCD. So steps 1 and 2 we are already familiar with, factoring and finding LCDs. That's what we did in the previous couple pages. And then determine the missing factor or missing factors. Notice I have the S in parentheses because it could be only one missing factor or more than one missing factor. So we're going to see that. That is, what factors does the LCD have that is or that are missing from the original denominator? And then we're going to multiply each fraction, numerator and denominator, by those missing factors. So we find the product and leave the denominator in factor form. So let's look at these examples right here. So number 1, we need to factor the denominator. So in this case, I'm going to factor the number 6 and I'm going to factor the number 20. So 6 is simply 2 times 3. These are prime numbers we just circled, and this is 2 times 3. And the number 20, that's 2 times 10, and then 2 times 5. Circle the prime numbers. 2 squared times 5. And then we are going to find the LCD. Alright, so the LCD will be factors of 2, factors of 3, factors of 5. In this case 2, we have it to the second power and to the first power. Highest power wins. In this case 2. But we need to go in this case with the variables as well. So we have a's here and there, one to the second power, the other one simply to the first power. So in this case we take the highest power. And finally we take powers of b. b is to the first power, b is to the third power. So 3b to the third power. So 2 squared equals to 4 times 3 times 5. A squared b cubed. That's a 12 times 5. Alright. And that's going to be 60 a squared plus b squared. Times b cubed. Alright. So now we are going to observe this LCD that I'm going to highlight with pink. And what are we going to do here? We are going to transform these two rational expressions into equivalent rational expressions that display this denominator. So for example, 3 divided by 6a squared b. So what do I need to multiply numerator and denominator so that I get a 60, a to the second power, b to the third power? Well, in this case, this 6 needs to become a 60 by being multiplied by 10. Okay. Now we're done with the numbers. Now let's go with the powers of a and b. So notice a, we have it to the second power already, so no need to add any additional powers of a. Let's go with b. B, we have it to the first power. How many more powers of b do we need in order to obtain a b to the third power? Well, we need 2 more, because 1 plus 2 equals power 3. So let's multiply across. 3 times 10, that's 30. B squared over 6 times 10, which is 60. A squared b cubed. So we just transformed this rational expression into an equivalent one that displays a least common denominator with the other fraction. Now let's see. And so let's do the same with the next fraction. So negative 5 over 20 ab cubed. So this 20 needs to be multiplied by what number to get a 60? Well, in this case, we need to multiply that by 3. Multiply both the numerator and the denominator. Now let's go with the powers of a and b. So we have a to the first power, but we need to have it to the second power. That means we need 1 more power. And well, a times a, that's a squared. Well, we're essentially done, because in this case we have b cubed. We don't need to add any powers of b. So now all we do is multiply across, multiply across. Negative 5 times 3, that's a negative 15. A divided by 60, a squared b cubed. So what happened here? In summary, what we did is to transform 2 fractions into new fractions that are equivalent, but now they have a common denominator. And I'm going to highlight it for you just so you can see how these are the same. So let's do it with polynomials this time. What do we need to do first? Write each denominator in factor form and find the LCD. So that's what we're going to do first. So in this case, we have a trinomial whose leading coefficient is 1. We're going to use the double bubble method. Oops, I don't need the end here yet. Not yet. So factors up to that add up to 3 plus 2 plus 1. And then in this case, I'm going to factor out the difference of squares. X plus 3, x minus 3. 9 over that. And I don't think I needed to write this. I wrote this too soon. So let me erase this part. Okay, so let me do one at a time. Maybe end x plus 3, x minus 3. All right, x plus 3, x minus 3. All right, so we need to find the LCD. So the LCD will be the product of every single distinct factor. That is, we have x plus 2. Well, you know what? I need to make a change, otherwise it's not gonna work the way I want it to. Wanted it to work. So this has to be. I'm sorry about this silly mistake. This has to be a 4, not a 2, not a 9 actually. And this is gonna change the entire game here. Those 3's are going to become a 2. Okay, so x plus 2, x minus 2, that's the factor form of the difference of squares. So the LCD will be form of the product of the distinct factors. In this case, I have an x plus 2, and then I have an x minus 1, and then an x minus 2. Those are the distinct factors. So that's the LCD. So our goal is to rewrite these two expressions in a way that they have this denominator, which is the common denominator. So x plus 2, x plus 1, which factor is missing from the LCD? Well, we have x plus 2, x plus 1. The only one that we are missing is x minus 2. So we are going to multiply by x minus 2, x minus 2. Okay. And then let's observe the second fraction, x plus 2, x minus 2. So we have x plus 2 and x minus 2. We are missing this factor of x plus 1. So in this case, well, let's just multiply across without distributing. Again, we need to leave everything in factored form. So we are going to get 4 times x minus 2. That's simply 4 times x minus 2, x plus 2, x plus 1, x minus 2. And for the second fraction, we are going to have 9 times x plus 1, x plus 2, x minus 2, x plus 1. I know what you're thinking. Well, in this case I have x plus 1, x plus 2, x plus 1, x minus 2, and here I have them in reverse order. But in this case, keep in mind that multiplication is commutative, so like 3 times 2 and 2 times 3, it's the same thing. So same with algebraic expressions. So now what did we do? We transformed these two given expressions right here. These two, we wrote them in an equivalent version that have an LCD, which is this one right here. Let's do one more. And we finish this section actually. So 3 divided by this trinomial, 5 divided by that trinomial. So we need to factor out 3x. Well, actually we factor only the denominator. We're using the double bubble method, factors of -7 that add up to -6. So x minus 7, x plus 1, because -7 times 1 is -7, and -7 plus 1 is -6. I'm going to leave some space for missing factors. I'm going to write the word int, and I'm going to do the same with the second fraction. So I'm going to use the double bubble method again. Factors of 21 that add up to -4. Those are negative. Actually, there's another silly typo, otherwise it's not going to work. So this one needs to be negative here. Okay, let me erase this one so that I can have the negative sign. So minus. So minus 7 and plus 3. Yes, otherwise I wouldn't have been able to factor the trinomial. Okay, so let's find the LCD. The LCD will be the product of all the distinct factors. So x minus 7 is one of the factors. Another distinct factor is this one, x plus 1. And the last one, x plus 3, is another. It's another missing factor. So let's highlight the LCD. So we need to look for the missing factors for the first fraction. Well, we have x minus 7 and x plus 1. We need one more, x plus 3. So we need to multiply numerator and denominator by that missing factor. Actually, x plus 3. All right. And then all we do is multiply across 3x times x plus 3 to leave everything in terms of a single fraction. X minus 7, x plus 1, x plus 3. And, well, we have x minus 7 for the second fraction and x plus 3. We are missing this x plus 1 factor. Multiplying across 5 times x plus 1 and x minus 7, x plus 3, x plus 1. Alright, and now we transformed these two fractions into equivalent fractions that contain the same denominator as the LCD. So where are we going to be doing all this? Well, we're going to be applying this in the following section when we combine fractions that have different denominator. So this is the end of this section. I'll see you on the next video.